Hi students, today we're going to be talking about integers and absolute value. So first let's talk about what an integer is. An integer is a number, and this includes not just the numbers that we're used to working with, positive whole numbers like 1, 2, 3, 4, 5, but it also includes their opposites. And their opposites would be numbers that are on the other side of the number line behind the 0. 0 is also an integer. So we're used to kind of seeing this side of the number line over here with the positives, but we actually have a matching number line in the opposite direction that contains negative numbers. And so integers would be those negatives, 0, and positive numbers on the number line. Now, when we're looking at integers, every integer has an opposite. So what that means is that every number, whether it's positive or negative, has another number that is the same distance from 0. So if you think of 0 as the center of the number line, if I'm looking at the number 5, we can see that 5 is 1, 2, 3, 4, 5 spaces from 0 on the number line. Well, its opposite is also 5 spaces from 0, but in the other direction. So we would go 1, 2, 3, 4, 5 spaces. So -5 and +5 are what we call opposites of each other. Now, when we're talking about opposites, we're talking about a distance. And that distance has a name called absolute value. So the absolute value is the distance a number is from 0 on the number line. Now, I want you to think about measuring distances. So if you were to take out a ruler, and we were to look at our ruler, so I've grabbed a ruler here. Rulers only have positive numbers on them, right? So if we think about this, a distance has to be positive. So we call that the absolute value. Now you see these little lines here on the side of the number? Those are absolute value symbols. So when you see that line, that's telling you, okay, we want to know how far, what is the distance that -4 is from 0. So if we're looking at -4 and we're looking at 0, the distance is 1, 2, 3, 4 spaces. If we were to take out our ruler and measure that, it would measure 4 spaces. So we say that the absolute value of -4 is 4. Well, just like that, +4 is 1, 2, 3, 4 spaces from 0. So the absolute value of +4 is also 4. They're both the same distance from 0, just in opposite directions. So that's why we call those opposites. So we're going to practice finding some absolute values. So the absolute value of -3, again, that's what this notation means. The absolute value of -3. So we're looking at our number line. We're measuring that distance from 0 to -3. The distance is 3 units. 1, 2, 3 spaces. So our absolute value is 3. So hopefully you're noticing that, oh my goodness, absolute values are always positive, right? An absolute value, because it's a distance, will always be positive. So let's practice. The absolute value of -8, well, how many spaces is -8 from 0? Well, it's 8 spaces to the left of 0. -5 is 5 spaces to the left of 0. So the absolute value of -8 is 8. So when we're doing our practice problems in our assignment today, we just write the problem down. And for these ones, the only work we would have to show is just writing down that one step. Some of them are going to get a little harder as we go on, but for now, that's where we're going to start. All right, this one, again, these lines here mean absolute value. So the absolute value of 5 is 5 spaces from 0. Now notice this next problem. Always pay attention. This is not asking us for the absolute value. This is just asking us about the number -5. Well, -5, we're not taking its absolute value. So it wants us to compare these numbers. So when I compare 8 and 5, 8 is greater than 5. So the absolute value of 8 is greater than the absolute value of -5. Now the absolute value of 5 is 5, but they didn't ask us about the absolute value here. So I'm comparing 5 to -5, and 5 is greater than -5. All right, let's practice reading a table. So we're looking at this table, and when I read a table, I really want to pay attention to the labels. The labels tell me what's happening. So I've got a substance, an item, butter, airplane fruit, honey, mercury, candle wax, and I've got its freezing point. So that's the temperature when that item changes from liquid to solid. So at 35 degrees Celsius, that's when butter becomes solid. So when, if we warm it up too much, it kind of melts and it's a liquid. Well, at the temperature 35 degrees Celsius, it would be solid butter versus liquid butter. Okay? So same thing for all of these. That's what these temperatures mean. So question A says, which substance in the table has the lowest freezing point? So I'm looking for the smallest number. Now when I'm thinking of my number line, larger numbers are to the right, smaller numbers are to the left. So I'm thinking of the smallest number would be the number the furthest to the left. So see what's happening to the numbers over here as I'm looking at the negatives? It's going in reverse. So that tells me that airplane fruit is the smallest integer up there. So it has the lowest freezing point. Okay, if we're looking at problem B, problem B says, is the freezing point of mercury or butter closer to 0? Well, let's take a look at this. Mercury is at -39. So that would be like right here on the number line, 39 spaces from 0. And butter, it would be over here at 35. So from 0 to 35 would be 35 spaces. From -39 to 0, this would be 39 spaces. So which one's closer to 0? The 35. So that tells us that butter is closer to 0.